Welcome everybody. Welcome to the Jamb Master Live Chemistry class. You're all welcome to the Jamb Master Live Chemistry class. As soon as you come in, welcome. This is day 2. This is day 2. The Jamb Master Live Chemistry class. And we're not wasting any time today. We're starting straight away. This is day 2 of the Jamb Master Live Chemistry class. Day 2 of the Jamb Master Live Chemistry class. This is day 2. You're all welcome. Let us get started. No time to waste. So day 1, we already covered some topics for day 1. This is day 2. In case you're just joining us for day 2, don't worry, the videos for day 1 are available already. You don't need to bother yourself. So day 2, these are the topics we must cover today. We must cover chemical equations. When we say chemical equations, we teach you chemical equations and how to balance chemical equations. We're going to teach you reacting masses calculations. Yes, reacting masses calculations. We're going to teach you limiting reagent calculations, all stoichiometric calculations. Yes, all stoichiometric calculations. Mole ratio. We're going to teach you mole ratio. Yes, mole ratio. Yes. We're also going to teach you concentration of solution. And we're going to teach you dilution formula. So get your writing materials ready and let us get started. Get your writing materials ready. Get rid of all distractions around you. Get your writing materials ready and let us get started. You are welcome. Yes. So let us start with chemical equation. Chemical equation. Let us start with chemical equation. A chemical equation is a symbolic representation of a chemical reaction. A chemical equation is a symbolic representation of a chemical reaction. So a chemical equation represents what happens during a chemical reaction. We use the chemical equation to show theoretically what happens practically during a chemical reaction. So a chemical equation is almost like the theoretical representation of what takes place practically during a chemical reaction. Please take note. And the chemical equation shows the following. A proper chemical equation shows the following. You're going to see a reactant. The reactants are the ones on the left side of the equation. The left side of the equation, you see the reactants. You're going to see the products. The products are usually on the right side of the reaction. So everything on the left side of the reaction are the reactants, everything on the right are the products. It also shows the stoichiometric ratios. A chemical equation also shows the stoichiometric ratios. Yes. If you have 2A plus 3B to give 4C plus 5D, this number has 2, 3, 4, and 5 are called stoichiometric ratios. A proper chemical reaction will give the stoichiometric ratios of each component in the reaction. The stoichiometric ratios are the numbers before each component: 2A, 3B, 4C, 5D. Stoichiometric ratios. Please take note. Now, without wasting much time, let's go to examples of a chemical equation. Today I'm teaching you a very simple method of balancing any chemical equation. A very simple approach of balancing any chemical equation. A typical chemical equation, you say you have H2, let's give it the simplest one, plus O2 to give H2O. Class, this is H2 plus O2 to give H2O. Another thing the chemical equation shows is that it shows the physical states of the reactant and product. Please take note. So a proper chemical equation shows the reactant on the left, the product on the right, the stoichiometric ratios of each component, which I showed you. It also shows the physical states, class. If a component is a solid, you see S. S represents solid. S represents solid. If it's a liquid, you see L. L represents liquid. If it's a gas, you see G. G represents gas. Now, there's another one called AQ. That's when the solution is in an aqueous form. An aqueous form means that the component is in a solution of its ions. That means it is in its ionic form. Yes, it's ionic form. It's aqueous. AQ means aqueous form. When the component is in a solution of its ion, we say what? Is in aqueous form. AQ. So a good chemical equation will show the physical state of each component of the reaction. For example, now you see G, G, and G. They are all what? Gases. Class, a chemical reaction can either be homogeneous or heterogeneous. A chemical reaction can either be homogeneous or heterogeneous. Homogeneous or heterogeneous. Class, when do we say a reaction is homogeneous? This reaction on the board is homogeneous. Why? A reaction is said to be homogeneous when every component of the reaction exists in the same physical state. A reaction is said to be homogeneous when every component of the reaction exists in the same physical state. Look at this. You have gas, gas, gas. Every component of this reaction, they are all gases. Therefore, this reaction is what? An homogeneous reaction. But class, when we say a reaction is heterogeneous, when the components of the reaction are not all in the same phase. That means some may be solid, some may be liquid, some may be gas. You say the reaction is said to be what? Heterogeneous. Remember, we don't have much time, so please get that and let's move forward. Having understood that, the next thing we need to look at now, class, is balancing of a chemical reaction, balancing chemical equation. That's where I want to go to straight. Class, when do we say a chemical equation is balanced? Please, if I want to advise you, how do you follow our class? Follow our class by hitting the subscribe button below. Hit the subscribe button. If you are my student and you have not yet subscribed to our channel, that's not good enough. Hit the subscribe button below there. Be our member. Just hit the subscribe button. Now, please take note. Another good way you enjoy this class, when you are learning, even whether you are understanding or not, class, this is not going to be the last time you watch this video. Are we together? Watch this video and watch it to the end first. This is your first round. Now, after this class is over in the morning, when you have slept well and woken up in the morning with your fresh brain, take your time and watch it again. This time around with taking notes. Are we following class? So this is not going to be the last time you will see this class. So I don't want to see anybody in the comment section saying I don't understand. Say you are too fast. Say you are too late. This is an online class. I say this every day. This is an online class. You have the advantage to watch it as many times as you want. So there's no issue of say you are too fast. Say come again. You can actually even reduce the speed of your video. Do you know? It is a setting in YouTube that can allow you to reduce the speed of your watching. So you can reduce, if I'm too fast, you can reduce it with on your phone there, but you don't know. Yes, ask someone to show you. You can reduce the speed of this class in your phone there. But my point is that whether I'm fast or I'm slow, or you understand or you don't understand that I'm teaching students from different academic backgrounds. So I cannot be too slow and I cannot be too fast. I have to be balanced. Are we together? But the advantage you have is that this is online, not physical. Meaning that if you don't get anything that I taught, you can still go and watch it again and again and again. You can pause, listen again, watch again, and watch again. So please take note of that. So this is not going to be the last time you're going to watch it. I didn't mean this is the last time you're going to watch it, then you should be scared. I will have missed everything. I will not understand. No. Even yesterday's class is still live. It's still there. You can still watch it. the link that I sent to you to watch this video is the same link you can always use to watch it anytime you want. Anytime you want to watch this video, just save those links somewhere in your WhatsApp. Anytime you want to watch this video, just click again, it will take you straight to my YouTube. You will watch again and again, as many times as you want until you understand. Please, I will not do this again till the end of this challenge. So please take note of that. So I don't want to see anybody saying, I don't understand, I'm too fast, this. I've explained to you that this is an online class. We have a lot of topics to cover, we don't have time. So please take note of that. Now let's move forward. How do we know when a chemical equation is balanced? Class, first of all, you will list out all the atoms that are in the chemical equation. This chemical equation contains two atoms, hydrogen and oxygen. This chemical equation contains two atoms, hydrogen and oxygen. After listing the two atoms, class, you're going to ask yourself, account for how many hydrogen are present on the left hand side. How many hydrogen do you have on the left hand side? Class, you have just two hydrogens on the left hand side, two. Now check, how many hydrogen do you have on the right hand side? You also have two. So class, hydrogen is balanced. But class, I must tell you something. A chemical equation is balanced if every atom on the left hand side has the same number as on the right hand side. Then a chemical equation is balanced. I must tell you another thing, class. When we want to balance chemical equation, we don't balance molecules, we balance atoms. Notice that I did not bring H2O out. I brought hydrogen and oxygen. We only balance elements, atoms of elements. We only balance atoms of elements. We don't balance H2O. I did not say, let's bring out H2O and let us see if H2O is balanced. No. You don't balance compounds or molecules. You balance atoms of elements. Who are the elements present in this whole chemical equation? There are only two, hydrogen and oxygen. So bring out hydrogen and bring out oxygen. Once you can balance hydrogen and oxygen, the chemical equation will be balanced automatically. So class, the method I'm using now is a try and error method. But like I said, I will teach you the algebraic method of balancing any chemical equation. I will teach you how to use algebra to balance any chemical equation. Follow me. You will learn a lot this side. So class, first things first, bring out all the atoms, hydrogen and what? Oxygen. We have hydrogen, we have oxygen. Now, how many hydrogen do you have on the left hand side? Two hydrogens. On the right hand side, H2, two hydrogens. So hydrogen is balanced. Now let's go to oxygen. On the left hand side, you have two oxygens. But on the right hand side, you only have one oxygen. So oxygen is not balanced. Class, as long as one atom in a chemical equation is not balanced, then the chemical equation is not balanced. If one atom in an equation is not balanced, then the whole chemical equation is not balanced. For a chemical equation to be balanced, every atom in the equation must be balanced. What do I mean by every atom in the equation must be balanced? That means the number of atoms on the left hand side must be equal to the number of atoms on the right hand side. The number of atoms on the left hand side must be equal to the number of atoms on the right hand side. So because we have two oxygens on the left hand side, but we only have one oxygen on the right hand side, therefore oxygen is not balanced. We have to do something about oxygen. But guys, you know the funny thing? When trying to balance a chemical equation, because oxygen is not balanced, by trying to balance oxygen, we end up unbalancing hydrogen. Because what do we take for oxygen to be balanced? We have two oxygens here, class. Class, in balancing chemical equation, you cannot reduce, you can only increase. You cannot reduce, you can only increase. What do I mean? You have one oxygen here, but you have two oxygen here. You cannot say, let me remove these two. And so oxygen will now be 1, 1. You cannot reduce. You can only do what? Increase. So if it's 2 here, it means that our target line is to get to 2 on this side. One more thing you should learn about balancing chemical equation. When balancing chemical equation, class, you cannot tamper with these numbers below here. These 2, 2, and 2. You cannot change them. Class, the only sides you can balance a chemical equation is on the stoichiometric position. Those numbers here. Look at this position. These are the only places you can affect a chemical equation. You can only affect the chemical equation from the stoichiometric positions. Class, you are not allowed to tamper with the numbers here. These some smaller numbers. You are not allowed to tamper with them, class. If you tamper with them, you will cause what we call a stoichiometric imbalance. You're going to cause what we call a stoichiometric imbalance. You're going to affect the chemical identity of the components of the chemical equation. Class, imagine changing oxygen from 2 to 1. When we all know that oxygen is a diatomic atom. You know, there are some elements that are diatomic. Elements that exist in what? 2 atoms. Oxygen is one of them. It's diatomic. Hydrogen is diatomic. Chlorine is diatomic. So class, you don't tamper with all atoms like this. You don't change these, their numbers. If not, you affect the whole chemical identity of the atom. The only thing you can do is you can add something behind them like this. But you cannot change these numbers below. Please take notes. So class, I want to make, oxygen is 2 here. and this oxygen is 1. I need to make this oxygen 2. Like I said earlier, there's 1 oxygen, there's 2 oxygen here. I cannot say let me remove these 2 now so they can be 1 1. No, you cannot reduce, you can only increase. When balancing chemical equation, you cannot reduce, you can only increase. Please take note. So, class, I want to make this oxygen on this side 2. I cannot put 2 here because, class, you cannot tamper with anything here, you cannot add anything below here, class. The only way you can affect the chemical equation is behind, like this. So I need to put 2 here. By putting 2 here, I affected oxygen because oxygen is now 2. And my oxygens are now balanced. But by putting 2 here, I have now increased hydrogen. Before this 2 was here, hydrogen was just 2. But by putting this 2 here, this 2 not only affects oxygen, it also affects hydrogen. Hydrogen now becomes 2 times 2, 4. So my hydrogen on the right hand side has changed to 4, class. Because this is 2 times 2, 4 hydrogen. But we only have 2 hydrogens here. How can we make this guy 4? We now apply what? 2. Remember that these are the only places you can affect a reaction. These places you can affect the reaction from this place, but you cannot affect them from this side. You cannot change anything below. But you can change behind like this. So by putting 2 here, 2 times 2 gives you what? 4. So that my hydrogen is now balanced. Let me check if nothing is wrong with my life. Before we continue, let me check if everything is still clear. If you are with us, say sir, I am with you. If you are with us, say sir, I am with you. If you are with us, say sir, I am with you. If you are with us, say sir, I am with you. If you are with us, say sir, I am with you. If you are with us, say sir, I am with you. From London hotels. Because after now, I'm going to be teaching you how to use algebra to balance chemical equations. I'm going to be teaching you how to use algebra to balance chemical equations. Please, I want to this. So, okay, good. My class, I confirm my class is clear, it's going well. Let's continue. So, class, we have 4 hydrogens. 2 oxygens. Everybody is now balanced. But class, let us apply the rules of algebra to balance this same chemical equation. The method we just use now is the trial and error method. Trial and error method. Trial and error method means that you balance one side, another side becomes unbalanced. You now balance this side, you now keep going like this and like this. And you don't have that time in the exam. That's why I must teach you what? The next method I'm teaching is algebra. So everybody write down your book, Balancing Chemical Equation by Algebra. I doubt they taught you this in your secondary school. I'm not sure they taught you this in your secondary school. This high-level university balancing of chemical equation. I teach this to my 100 level, 200 level chemistry students. But I'm going to give it to you today. Use it and you clear your Jamb. There are some knowledge level you have that is higher than Jamb. When you enter Jamb becomes very easy for you. So I'm giving you a higher level. Only very few secondary schools taught balancing of chemical equation by algebra. So write down your book, How to Balance Chemical Equation by Algebra Method. So let's return the equation back to its former state. How to balance chemical equation by algebra method. Step 1, right now, step 1. Step 1 represents each component of the reaction. Represent each component of the reaction with unknown letters A, B, C. Represent each component of the reaction with unknown letters A, B, C. Step 2. Let A be equal to 1. Let A be equal to 1. Step 3. Form an equation for each atom of elements in the equation. For each atom of elements in the reaction. Form an equation for each atom of elements in the reaction. Step 4. Solve for what? The unknown letters A, B, C. Solve for 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 the unknown letters A, B, C. Class, I'm going to apply this. When I apply it, you will not need to cram this. When I apply it, when I teach you how to apply this, you will not need to cram it. Step 1 says represent each component of the reaction with unknown letters A, B, C. Step 2 says let A be equal to 1. Step 3 says form an equation for each atom of element in the reaction. Step 4 says solve for the unknown letters A, B, C. Let us go, class. Let us go. Let us go. It's time to clean. If you didn't get it, please just rewind the video. This is an online class. Remember, there's no time. This is an online class. Let us apply. And don't forget, you can still watch this again. So you can just watch this as your first watch. You can watch this as your first watch. Say, okay, let me just flow with the class. My second watch, I will not take time to really slow down, understand? But let me just flow with the class. Let me just flow with the class, my first watch. Tomorrow morning when you wake up, watch again. The link that brought you here can allow you to watch the class again. Class, let's apply these steps. Step 1 says represent each component of the reaction with unknown letters A, B, C. Class, how many components does this reaction have? 1, 2, 3. So you're going to say A, put B here and put C here. A, B, C. We are just obey step 1. Represent each component of the reaction with unknown letters A, B, C. Step 2 say let A be equal to 1. Step 2 say let A be equal to 1. So A is 1. Step 3 now said we should what? Form an equation for each element, atom of element in the reaction. How many elements do we have in this reaction? We have H and we have what? O. Class, we are going to form an equation for H and form an equation for O. Let us form an equation for H. Class, how do you form an equation for H, class? For H, on the left hand side, this A and this 2. What are we supposed to do? We say 2 times A, 2A. So for hydrogen on the left hand side, you have 2 times A, 2A equals to, on the right hand side, hydrogen is C, 2 times C, 2C. So class, the equation for hydrogen is 2A equals to 2C. Class, this is not time to say I don't understand. This is a new thing you are learning. Of course, you will not understand. When you were in primary school, it's not the first day you learned A to Z that you knew it. As simple as A to Z is, it was not the first day you entered school that you learned A to Z. It took you time, right? You kept saying it A, B, C, D, E, F, G, A, B, C, D, E, F, G. You kept saying A to Z till you knew it, right? You kept practicing till you knew. So calm down, be relaxed. Let me come again. Let me come again. Class, we have to form an equation for each atom of element in the reaction. Notice I did not form an equation for H2. H2 is not an element. It's a compound. It's a molecule. We don't form equation for molecule. When balancing chemical equation, we are not trying to balance molecules. We are trying to balance atoms. There are only two elements, atoms of element present in this reaction, hydrogen and oxygen. Now I start with hydrogen. 2 times A on the left hand side, hydrogen is 2 times A, 2A, equals to on the right hand side, hydrogen is C, 2 times C, 2C. Let's form an equation for oxygen. On the left hand side, oxygen is 2 times B, 2B, equals to oxygen on this side. Class, this C affects both hydrogen and oxygen. Class, any letter or any number behind here affects everybody in the compound. So this C is not just for hydrogen, it's also for oxygen. Class, we only have one oxygen here, so 1 times C, 1C. Class, we now have an equation for hydrogen and we have an equation for oxygen. It's now time to solve the equations and get our value of A, B, and C. Class, don't forget that we have said let A be equal to 1. Means anywhere we see A, we can put 1. Anywhere we see A, we can put 1. This will now mean that 2 into bracket 1 equals to 2C. 2 times 1 is 2. 2 equals to 2C. Let us divide both sides by 2. So that C is 2 divided by 2 is what? 1. So that C is what? 1. So we have gotten A as 1 and C as 1. Class, if C is 1, we can come to the second equation and replace C as 1 so that we can get B. Since C is 1, come to equation 2 and replace C as 1 so that we can get B. This will imply that 2b will be equal to 1 times c. Who is c? C is 1. So that 2b equals to 1 times 1 is 1. Let us make b subject of the formula. Divide both sides by 2. So that b is 1 all over 2. Class, we have gotten A, B, and C, but there's a problem. Anytime you get your unknown values and one of them is a fraction, then there's fire on the mountain. There's something you must do to calm that fire. Class, you're going to multiply all the numbers by the denominator of the fraction you got. What is the denominator of the fraction? 2. We're going to multiply A by 2, C by 2, and B by 2 to cancel out this denominator. So A is 1 currently. We're going to say A is now going to be 1 times 2, which is 2. C is 1 currently. C will be 1 times 2, which is 2. And B is 1 over 2. So B will be 1 over 2 multiplied by 2. So that 2 cancels 2 and B is now 1. So class, our final unknown letters have now been obtained. Our final unknown letters have now been obtained. And we now know that A is what? 2. B is 1, and C is 2. Now come back to the equation and replace A, B, and C with their new values. A is what? 2. B is 1, and C is 2. And you have ended up balancing the chemical equation. Now, I know there's something that's going on in your mind. It is not longer than the trial and error method. No, it's not longer. It is only longer because you're not learning for the first time. If I was solving this alone in the exam class, I would have been done since. If I was solving this alone in the exam, I would have been done since. The trial and error method was fast because this is a simple equation. There's a kind of question they will give you in your Jamb to balance. That your trial and error method, have you made that kind of equation before? But you're trying to balance one thing, you balance another thing. You balance one thing, another thing gets unbalanced. Only the algebraic method can deal with it. Our way together. Now, if you do not understand, it is normal. I don't expect you to understand perfectly. You're not perfect. Nobody's perfect. I will take more examples. As we are practicing, practice makes perfect. The more we are together, the happier we shall be. The more we are together, the happier we shall be. So let's go, class. Let us take another example. No need to come back with this. Let us instead take another example. The only thing I will come back with is anytime you get a fraction, take note of the denominator of the fraction and multiply all through by the denominator of the fraction. The denominator here is 2. That's why we multiply all our answers here by 2. And we have 2, 2, 1. Please take note. Let's take another question. As we are doing it, we get better. Instead of wasting time on just one question, let us make progress. Let us take another question. Still use algebraic method until you get it. If you have gotten it already, say, sir, I understand. There are some very few students that have already understood already. Sir, I understand. Some have understand already. Let me see your comment in the comment section. Sir, I understand already. Sir, well done. Fire down, sir. Sir, I understand already. Sir, I understand already. Sir, I understand already. Let us try to balance this. Cu plus HNO3 to give Cu NO3 2 plus NO plus H2O. Cu plus HNO3 to give CuNO3 2 plus NO plus H2O. Class, follow me. If you did not get that first example, this is time to pay attention carefully. This is time to pay attention carefully. If you are still here, say, sir, I am still here. Let us make our commitment before we move forward. Let us make our commitment for today before we move forward. Let us commit that we will not live till the end. Type, I will not live till the end. I will not live till the end. Type it in the comment section. Find the comment section wherever you're watching the video and type it. I will not live till the end. Jamb is very close. Jamb is just next month, 16th of April. No time to waste. I will not live till the end. Let's go. Class, the rule is represent each component of the equation with unknown letters. So this will be A, this will be B, this will be C, this will be D, and this will be E. Every component of the equation should have their own letters. So this is A, B, C, D, E. Now, step 2, say let A be equal to 1. We have obeyed step 2, let A be equal to 1. Step 3 now said, form an equation for every element in the reaction. How many elements do we have in this reaction? Class, follow me carefully. We have Cu, we have H, we have N, and we have oxygen. Class, these are the only elements in the reaction. Remember I told you we balance only atoms of elements. We don't balance compounds. So you will not see me bringing out HNO3. You will not see me bringing out NO or H2O or CuNO3 to know. I just bring out the atoms Cu, H, N, and O. Now try to form an equation for each of them. Try to form an equation for each of them. Let us start with Cu. Class, Cu is A on the left hand side. So this is A. On the right hand side, Cu is bearing C. So A equals to C. Cu is very simple and straightforward. Let us go to hydrogen. Class, on the left hand side, hydrogen is B. On the right hand side, hydrogen is E, but 2 times E, 2E. So B equals to 2E. Class, this is the equation for hydrogen. B equals to 2E. Let's form an equation for nitrogen. You see it's getting better now, right? When you have understood it, this is faster than... Okay, imagine trying to use trial and error method before you will finish. Nitrogen, N. On the left hand side, N is carrying B. Don't forget that this B affects everybody in this compound, not just hydrogen. So this B is also for nitrogen. So for nitrogen, we have B equals to... Where is nitrogen on this side, class? We have nitrogen occurring twice on this side, here and here. For nitrogen here, this 2 in this bracket affects nitrogen. So nitrogen is 2. And this C affects everybody in this compound. So nitrogen is 2, 2 times C, 2C. 2C on the right hand side. Remember, B on the left hand side, nitrogen is just B on the left hand side. But on the right hand side, this nitrogen is carrying 2 because this 2 affects everybody in this bracket. So nitrogen is 2 times C, 2C plus, don't forget, there's another nitrogen here carrying D plus D. This is the equation for nitrogen, class. If you are getting something, say, sir, I am getting something. Sir, I am getting something in this class. Oxygen. On the left hand side, oxygen is 3, but B, this B affects oxygen. 3 times B. 3B. Where is oxygen on this side, class? Oxygen occurs here, and occurs here. The oxygen on this side is 3 times 2, 6. 3 oxygen times 2, 6. 6 times C. 6C plus, this D also affects oxygen, plus D, plus, this E also affects oxygen, plus E. This is the equation for oxygen. Class, we have successfully formed an equation for every component of every atom in the equation. It's now time to solve for the unknown letters. Class, we are lucky, A is 1. Remember, let A be equal to 1. But equation 1 says let A is equal to C. So if A is 1, it means C is also 1. Plus, it helps that we have gotten 2 unknowns already. It helps that we have gotten 2 unknowns already. So A is 1, C is 1. Now, where can we put C? We can put C inside here. So that we now have that B equals to 2C. Who is C? C is 1. So 2 times 1 is 2. Plus D. 2 plus D. B equals to 2 plus D. B equals to 2 plus D. But class, watch here. 3B equals to 6C plus D plus E. C is 1, don't forget. So this now implies that 3B equals to what? 6 plus D plus E. 3B equals to 6 plus D plus E. 3B equals to 6 plus D plus E. But class, from this equation, B is equals to 2 plus D, right? B is equals to 2 plus D. So anywhere we see B, we can put 2 plus D. Anywhere we see B, we can put 2 plus D. Anywhere we see B, we can put 2 plus D. Another thing we can do, yes, so let's put 2 plus D there. So we're going to say 3 into bracket 2 plus D equals to 6 plus D plus E. 6 plus D plus E. So 3 times 2 is 6. 3 times D is 3D plus 6 equals to 6 plus D plus E. Let us collect like terms. We have D here and let D come to this side, let 6 come to this side. So this is going to be 3D When plus D comes, it becomes minus D equals to what's left here, 6. When 6 comes to this side, minus 6. There's already 6 here, but when the 6 moves to this side, it becomes minus 6. Plus E. 6 minus 6 is 0. 6 minus 6 is 0. So 3D minus D is 2D equals to E. We are left with 2D equals to E. 2D equals to E. 2D equals to E. So it means that E is 2D. E is 2D. E is 2D. Please take note. E is 2D. E equals to 2D. Now let's keep going. If 2D equals to E, it means anywhere we see E, we can put 2D. Anywhere we see E, we can put 2D. So replace E here with 2D. What are we going to have? Since B is 2E and E is 2D, because this, if 2D is E, it implies that what? E is equals to 2D. So anywhere I see E, I can put 2D. So that implies that B now equals to 2 into bracket 2D. Instead of 2E, E is 2D, right? So that B is now equal to what? 2 times 2D, 4D. So B is 4D. B is 4D. B equals to 4D. B equals to 4D. So anyways, anywhere I see B, I can put 4D. Anywhere I see B, I can put 4D. Look at it. It means I can replace this B with 4D. I can replace this B with 4D. So I'm going to have 4D. Instead of this B, I have 4D equals to 2 plus D. 4D equals to 2 plus D. Bring D over to this side. You have 4D minus D equals to 2. 4D minus D is 3D equals to 2. Divide both sides by 3 to make this solid formula. So D is 2 over 3. D is 2 over 3. So A is 1, C is 1, D is 2 over 3. A is 1, C is 1, D is 2 over 3. If D is 2 over 3, don't forget that E equals to 2D. E equals to 2D. And also B equals to 4D, and D is 2 over 3. B equals to 4D. So this implies that B must be equal to what? 4 times 2 over 3. 4 times 2 is what? 8 all over 3. So it means we have gotten B as 8 all over 3. So B is 8 all over 3. Class is only slow because I'm teaching. If I was one solving on my own, I'll be faster than this. Now the remaining E we are looking for. E is 2D. Although questions like this, you solve them last. I told you in the smart Jamb approach. Don't be that with my live session. Never attempt tough questions first. Never attempt tough questions first. Even if you get it, it will stretch it. It will take more than you will lose more than you gain. E is 2D. Who is D? D is 2 over 3. That is 2 into bracket 2 over 3. 2 times 2 is 4 all over 3. So E is 4 all over 3. E is 4 all over 3. So class, we've gotten all our unknown letters. The only problem now is that we have a fraction. What do we do when we have a fraction? What do we do when we have a fraction? We multiply all through by the denominator of the fraction, right? Everybody must be multiplied by 3 because the denominator is 3. Look at it. Everybody must be multiplied by 3. So since we are doing chemical equations, I can clean this part so I need as much space as possible. So I'm going to say A is 1. So A will now be 1 times 3, which is 3. C is 1. C will now be, let's go with B. B is what? 8 over 3. 8 over 3 times 3. 3 cancels 3. B is now going to be 8 after multiplying by 3. C is 1. 1 times 3 will give you 3. D is 2 over 3. 2 over 3 times 3. 3 cancels 3, leaving 2. D is 2. And E is 4 over 3. 4 over 3 times 3. 3 cancels 3, leaving 4. And class, our equation can now be expressed. Our equation can now be expressed. Remember that this is, instead of A is now what? 3. Instead of B is now 8. Instead of C is now 3. Instead of D is now 2. Instead of E is now 4. And if you check it, the equation is completely balanced. The equation is completely balanced. Guys, I gave you the toughest question as possible by preparing for a tough Jamb exam. You know, yesterday some people were saying that yesterday's class was too simple. I hope you are still saying that now. I told you that as we are going forward, we are going to tougher topics. I told you, hope you are ready now. Yes, some people were saying how yesterday's class is simple, this one is simple. That was the first chapter, that's why it's simple. As we are going higher, we're not going to organic chemistry, electrolysis. We're getting there. So look, as you can see, this is balancing of chemical equation with algebra. You see that you need to take your time and go and watch this video again. Because we cannot be stopping for you now, there's no time. You need to take your time and go and watch this video again. Let's just take one more question. Please allow me to clean the board. You can rewind and look at it again. I hope my light is still on. I hope no issues. Okay, no issues. It's still showing clearly. Let's go. Thank God. Now, one more question, and we'll say bye-bye to balancing of chemical equation. You should not have any issue with balancing chemical equation again. Class, I just give you the toughest question possible. Let's take one more question. PB 304 plus H2 to give PB plus H2O. PB 304 plus H2 to give PB plus H2O. Class, what's the first step? By now you must have gotten some things. Represent A, B, C, D. That's the first step, right? Represent every component of the equation with unknown letters. A, B, C, D. Step 2, let A be equal to 1. Step 3, form an equation for every atom of element in the equation. How many elements do you have in this equation? We have PB, lead. We have oxygen. We have hydrogen. There are only 3 atoms of elements in the equation. Now let's form equation for PB. PB is 3 times A, 3A. PB is C on the right hand side. Oxygen is 4, or 4 times, this A affects everybody inside. Remember, this A is for everybody. 4 times A. 4A equals to, what is oxygen here? This D affects oxygen. There's only one oxygen here, 1 times D, D. Hydrogen, 2 times B, 2B equals to 2 times D, 2D. Class, we have formed an equation. This question is even simpler than the other one. Now that we have formed an equation, class, don't forget A is 1. If A is 1, I can replace A as 1. You are going to have 3 into bracket 1 equals to C. So 3 times 1 is 3, so C is equal to 3. So C is 3. If C is 3, class, A is 1, don't forget 4 equals to D. Means that 4 times 1 equals to D. So that D equals to 4. So D is 4. Who else don't we have? Who don't we have yet? We have A, we have C, we have D. It's only B we are looking for. If D is 4, we can come here. 2B equals to 2D. 2B equals to 2D. So 2B equals to 2 times, who is D? 4. 2B equals 2 times 4 is 8. Divide both sides by 2. 8 divided by 2 is what? 4. So B is also 4. Class, this is the first question we have solved that did not give us any fraction. So no need to multiply by denominator. Just enjoy. So A is 1, replace A as 1 here. B is 4, replace B as 4. C is 3, replace C as 3. And D is 4, replace D as 4. Let me teach you something when you are learning. Some of you, why you don't understand things is because you are impatient. Let me tell you something. If someone is teaching you something for the first time and they give the first example, it's normal that you don't understand. Just continue the class. If I don't go back, continue the class. Before you finish 2-3 examples, something will click in your brain. Okay, this is what you did in that number 1. Okay, you get it. But impatience will not allow you, because of that number 1 you did not get, you now be angry. You now what? You now self-sabotage yourself. That's what we call self-sabotage. You now be angry. You now allow that one, that impatience. You now allow yourself to miss the other 2-3 examples that you would have just impatient. Let me just keep following first. I might get it later. Learn that from me. Imagine the first day you went to primary, the first day you enter school in this life, when you're a baby. Imagine that day, they taught A to Z. And because you do not know A to Z, you started crying, you started getting angry, you now left the school. Will you have known A to Z? As simple as A, B, C, D is, you did not learn it the first day, remember. But then as a baby, you don't even have choice. You just stayed. You kept saying it, you kept making mistakes. Do you know how many mistakes you made before you learned A to Z? Do you know how many mistakes you made before you learned 1, 2, 3, 4, 5? But because then you were a child, you had patience then. But now you want to learn this very fast. You don't want to just calm down. Let me take another. Let me look at the second example. Let me look at the third example. I think I will get it. That's the mistake. That's the problem of 80% of Nigerian students. Impatience. Let me look at the first example. There are some people that have been patient a bit, and I'm sure they have gotten it from the third example. Oh, this is what they are doing. Okay. Just a little patience. So I want to teach you, I want to train you to be a good student. Anytime I'm teaching something I don't understand first, calm down. Don't be in a hurry saying I don't understand, saying you're too fast. No, calm. Wait for second example, wait for third example, be patient, and you still have the chance to go and watch it again. I'm just trying to help you. Class, we have to leave chemical equations now and go to the next topic, reacting masses calculation. Reacting masses calculation. Reacting masses calculation. Class, we are getting to the calculation aspect now. We're just going to have to balance chemical equation. Class, in this aspect, there's no more time to waste, just to take question. Question 1. What mass of CO2 is produced when 24 grams of carbon bonds in oxygen What mass of CO2 is produced when 24 grams of carbon bonds in oxygen? Class, this is a reacting mass question. The equation, obviously, when we have C plus O2 to give CO2. Class, the first temptation they will give you in the exam, they will give you an equation that is not balanced. Most students will just start what? Solving without balancing it. But class, you are lucky, this particular equation is actually balanced. You are lucky. This particular equation is actually balanced. But please, before you start solving any question in stoichiometry, always identify if the equation is balanced or not. We are lucky this equation is balanced. Class, the next thing you need to find out after you find out the equation is balanced, ask yourself, in every reacting mass or stoichiometry question, there's always two elements that are linking each other. There are always two elements that we're going to use. What mass of CO2? So CO2 is produced. CO2 is the product. When 24 grams of carbon bonds in oxygen. So when 24 grams of carbon, class, no, 24 grams of carbon bonds, what mass of CO2 is produced? Let's call it X. We don't know. We don't. Class, one thing you have to learn how to do. Of course, they'll give you the atomic masses of carbon is 12, oxygen is 16. They'll give you this. One thing you have to do first, ask yourself, from the balanced chemical equation, what mass of carbon produces what mass of CO2 from the balanced chemical equation? Class, from the balanced chemical equation, carbon is 12 grams. And from the balanced chemical equation, CO2 is 12 plus oxygen is 16. 16 times 2, 32. Everything is 32 plus 12, 44 grams. So CO2 is 44 grams. Class, from the balanced chemical equation, 12 grams of carbon gave 44 grams of CO2 from the balanced chemical equation. Class, before you start answering their question, the question said, what mass of CO2 is produced from 24 grams of carbon, right? Leave this one aside. First ask yourself, from the balanced chemical equation, you see why the equation was balanced. And you see why I first taught you balancing of chemical equation first. From the balanced chemical equation, what mass of carbon gave what mass of CO2? 12 grams of carbon, because that make mass of carbon is 12. They will give you this in the exam, 12. 12 grams of carbon gave 44 grams. This one you have calculated 12. Carbon is 12. Oxygen is 16. 16 times 2, 32. 32 plus 12, 40. 12 grams of carbon gave 44 grams of CO2. Now 24 grams of carbon, we give how many grams of CO2? We don't know, call it X. We don't know, call it. We can then cross multiply. So that 12 times X is 12X. And 24 times 44 will now be equal to 24 times 44. We are now to divide both sides by 12. We are now to divide both sides by 12. So we're going to say 24 times 44 divided by 12. I'm on my calculator here. 24 times 44 is 1056. Now divided by 12 is 88. So therefore, class, 24 grams of carbon will produce 88 grams of CO2. If you are still following, say, sir, I'm with you. If you are still following, say, sir, we are with you. Say, sir, we are with you. If you are still following, say, sir, we are with you. This is 49 minutes live. 49 minutes. Say, sir, we are with you. 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 If you are still following, say, sir, we are with you. We are not going anywhere. I will not live till the end. I will not live till the end. I will not live till the end. Get ready for the next question. I'm just giving you small time. I don't want to rush you too much. Get ready for the next question. I will not live till the end. Get ready for the next question. Get ready for the next question. Get ready. The next question will challenge you more. The next question will challenge you more. The next question will challenge you more. The next question will challenge you. Get ready. 1 minute, and I'll take the question. Just give me 1 minute. Give me 1 minute. Get ready, get ready. Now let me give you a classwork. I'm sure you are done writing now. What mass, write this question, I'm dictating. What mass of calcium oxide is produced from 50 grams of calcium carbonate? What mass of calcium oxide is produced from 50 grams of calcium carbonate? What mass of calcium oxide is produced from 50 grams of calcium carbonate? What mass of calcium oxide is produced from 50 grams of calcium carbonate? What mass of calcium oxide is produced from 50 grams of calcium carbonate? What mass of calcium oxide is produced? What mass of calcium oxide is produced? What mass of calcium oxide is produced from 50 grams of calcium carbonates? Class, this is your classwork. Let me see what you can do. This is your classwork. Let me see what you can do. This is your classwork. Let me see what you can do. This is your classwork. I'm giving you 1 minute, please. First answer. I want to see the first answer. I want to see the first answer. My best student in Jamb this year. I want to see the first answer. I want to see the first answer. 1 minute. I'm giving you 1 minute to solve. Go ahead and solve. I'm waiting. Let me see the first answer. I want to see the first answer. I want to see the first answer. What mass of calcium oxide is produced from 50 grams of calcium carbonate? What mass of calcium oxide is produced from 50 grams of calcium carbonate? Let's do the correction. Let us do the correction. Class. It means that calcium carbonate produces calcium oxide. Calcium carbonate obviously is CaCO3. Class, oftentimes or not, they will give you the equation. CaCO3 to produce CaO plus CO2. Now, let's give you the atomic mass because Jamb usually gives you, they are generous. Calcium is 40, carbon is 12, oxygen is 16. Calcium is 40, carbon is 12, oxygen is 16. What mass of calcium oxide? So the business between calcium oxide and calcium carbonate. The business is between calcium oxide, which is CaO, and calcium carbonate, CaCO3. So it's obvious that calcium carbonate, CaCO3, undergoes decomposition to give CaO and CO2. If you're just joining us, welcome, join us, no time to waste. Now, the arsenal what mass of calcium oxide is produced from 50 grams of this guy. But before we do that, so 50 grams of this guy, they ask us to find what mass of this guy is from. We don't know, call it X. But leave this one aside and come to the balanced equation. Ask, is the equation balanced? Yes. 1 Ca, 1 Ca. 1 carbon, 1 carbon. O3, and we have 1 oxygen plus 2 oxygen, 3 oxygen. Everything is balanced. Let's find the mass of CaCO3 from the balanced chemical equation. Calcium is 40. Carbon is 12. Oxygen is 16. 16 times 3 is 48. If you add everything here, you're going to have 100 grams. From the balanced chemical equation, 100 grams of calcium carbonate, this calcium carbonate, CaCO3, gave what mass of CaO? Ca is 40, oxygen is 16. 40 plus 16 is 56 grams. From the balanced chemical equation, 100 grams of CaCO3 gave 56 grams of CaO. Now they're asking us, what is 50 grams? What mass of CaO will be got in X? We don't know. Because what mass of calcium oxide is produced when from 50 grams of calcium carbonate, from 50 grams of calcium. But class, you must first have your standard from the balanced chemical equation. 100 grams of CaCO3 gave 56 grams of CaO. Now 50 grams of CaCO3 will give what? X, you don't know. Cross and solve. 100 times X is 100X. 100 times X, 100X. 50 times 56 equals to 50 times. Divide both sides by 100 to make X solid of the formula. Divide both sides by 100 to make X solid of the formula. Then we solve 50 times 56 divided by 100. 50 times 56 is 2,800. Now divided by 100, you're going to have 28 grams. Who got this before I got it? If you got this, let me know in the comment section. Sir, this is what I got. Let me know in the comment section. Sir, I got it. Let me know in the comment section. Sir, I got it. Let me know in the comment section. Sir, I got it. Let me know in the comment section. Sir, I got it. Let me know in the comment section. Let me know in the comment section. Welcome, welcome, welcome. Welcome, welcome, welcome. If you are just joining, make sure you start the class from the beginning. Don't just forward it. This is not a movie. If you are just joining, make sure you start the class from the beginning. Start the class from the beginning. Start the class from the beginning. Whether you're just joining now or anytime, note that you can always watch it from the beginning. Class, let's look at one more question on reacting masses. Let's take this question. Calculate the mass of sodium trioxocarbonate 4 calculate the mass of sodium trioxocarbonate 4 produced by the complete decomposition of 16.8 gram of sodium hydroxide trioxocarbonate 4. Look at the equation here, 2NaHCO3 to give Na2CO3 plus H2O plus CO2. 2NaHCO3 to give Na2CO3 plus H2O plus CO2. Calculate the mass of sodium trioxocarbonate 4 produced by the complete decomposition of 16.8 gram of sodium hydroxide trioxocarbonate 4. Yes. Calculate the mass of sodium trioxocarbonate 4 produced by the complete decomposition of 16.8 gram of sodium hydroxide trioxocarbonate 4. Class. Mass of sodium trioxocarbonate, this is sodium trioxocarbonate produced. When this guy is decomposed, what mass of this is produced? Before you start solving, is the equation balanced or not? I think it's balanced. 2Na, Na2, balanced. Hydrogen, 2 hydrogen, 2 hydrogen, balanced. 2 carbon, these two are first carbon, 2 carbon, 1 carbon, 1 carbon, 2 carbon, balanced. Oxygen, 2 times 3, 6 oxygens. 3 oxygens here, plus 1, 4, plus 2, 6, balanced. Everything is balanced. Always ensure that the equation is balanced before you start solving. Now that you are sure that you are solving from a balanced equation, no, you are not wasting your time. Class, this stoichiometry between this guy and this guy. Calculate the mass of sodium trioxocarbonate 4. This is sodium trioxocarbonate 4 produced by complete decomposition of 16.8 gram of sodium hydroxide trioxocarbonate 4. This is sodium hydroxide trioxocarbonate 4. 16.8 gram of this guy was decomposed. What mass of this guy is formed? That's what they are telling us to find. If 16.8 gram of this guy is decomposed, what is the mass of this guy that is formed? Let's call it X, we don't know. But class, we need to find from the balanced equation, what's the mass of this guy that gave the mass of this guy from the balanced equation? Note that sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16. Let's find the molar mass of RMM, the relative molecular mass of NaHCO3. Na is what? 23. 23 times, 23 plus H is 1. Carbon is 12. Oxygen is 16 times 3, 48. Everything multiplied by 2. 23 plus 1, 24. 24 plus 12, 36. 36 plus 48. 36 plus 48. Should give you 84, I think. 84 times 2, let's use a calculator. 23 plus 1 plus 12 plus 48 equals 84, yes, times 2 equals 168. So total mass of this guy is 168 from the balanced chemical equation. Let's define the mass of this guy. This guy, because I know him before, I know it's 106 before now. But let's do it together. Sodium is 23 times 2, 46. Carbon is 12. Oxygen 16 times 3, 48. 16 times 3, 48. So we say 46 plus 12 plus 48. Yes, 106. So class, on the balanced chemical equation, 168 gram of this guy gave 106 gram of this guy. Now 16.8 gram of this guy will give what? X. You don't know. Cross, multiply. So we're going to have 168x, 168 times x, 168x equals to 16.8 times 106, 16.8 times 106. Now divide both sides by 168. Divide both sides by 168. You're going to say 16.8 times 106 divided by 168. 16.8 divided by 168. Everything will give us 10.6 grams. So class, the final answer here is 10.6 grams. The final answer here is 10.6 grams. I'll just give 30 seconds for you to write, then we'll go to the next topic. Class, that's reacting mass for you. That is reacting mass for you. That is reacting mass for you. So we're done with reacting mass. Next thing we're going is looking at limiting reagent calculation. Limiting reagent calculation. Please permit me to clean. You can always rewind and copy again. You can always rewind and copy again. You can always rewind and copy again. Let us look at limiting reagent now. Time for limiting reagent, class. Limiting reagents. Right, this is the reactant that is completely consumed first during a chemical reaction. This is the reactant that is completely consumed first. During a chemical reaction. This is the reactant that is completely consumed first during a chemical reaction. It determines the maximum amount of product that can be formed. It determines the maximum amount of product that can be formed. This is the reactant that is completely consumed first. Class, anytime two reactants react, one person usually finishes first. If you have a reactant A reacting with reactant B to give C, one of these two reactants finishes first. The reactant that finishes first is the one that controls the reaction, because once it finishes, the reaction stops. Class, a reaction will stop as soon as one of the reactants is no longer active. Class, when you buy provisions, you buy milk and you buy Milo. Which one is to finish first? Tell me. When you buy your provision, milk and Milo, which one finishes first? The one that finishes first is the limiting reagent. And that person is very powerful, because once he finishes, the other person cannot do anything again, because you need two reactants before a reaction can take place. This guy cannot be reacting with himself. So B needs A needs B. So whoever finishes first is the one that controls the reaction, because once he finishes, the reaction ends. Are we following, class? You can see here we said that it determines the maximum amount of product that can be formed. The limiting reagent determines the maximum amount of product that can be formed. What does that mean? Because the person that finishes first also determines where the product will stop being formed. Because as soon as the reaction stops, the product is no longer formed again. So whatever product has been formed before, that's where it will stop. This is why it determines the maximum product that can be formed. So the limiting reagent holds the key. Class, the next thing is to teach you how to determine limiting reagent. How do you know who will finish first in the reaction? Even without carrying out the reaction, there's a way to know who will finish first. There's a way to know the reactant that will finish first, even without carrying out the reaction. How to know the reactant that will finish first? How to know the reactant that will finish first? Write down steps used to determine limiting reagent. Steps used to determine limiting reagents. Steps used to determine limiting reagent. 1. Determine number of moles of each reactant. 2. Divide by their stoichiometric ratios. 3. The reactant with the least value is the limiting reagent. The reactant with the least value is the limiting reagent. I'll give you time to write it and I'll explain. I'll give you small time to write it and I'll explain. The reactant with the least value is the limiting reagent. The reactant with the least value becomes the limiting reagent. The reactant with the least value is the limiting reagent. Now let's take a question. Given that 3.2 gram of nitrogen reacted with 2.5 gram of hydrogen to form ammonia. One, determine the limiting reagents. Two, find the mass of ammonia produced. Find the mass of ammonia produced. Find the mass of ammonia produced. Given that 3.2 gram of nitrogen reacted with 2.5 gram of hydrogen to form ammonia, determine the limiting reagent, find the mass of ammonia produced. Class, nitrogen is N2 to give H2. N2 plus A2 give Na3. Ammonia is Na3. To balance the equation, we'll put 3 here and put 2 here, and the equation is balanced. N2 plus 3A2 to give 2Na3. Now, class, the first question says we should determine the limiting reagent. Class, I give you 3 steps to determine limiting reagent. The first step, now note that nitrogen is 14 grams. But since it's diatomic, it exists as N2 is 28 grams. 1 mole of nitrogen is 28 grams. And hydrogen obviously is 1 gram, but H2 will be 2 grams. If you're using H2, it's 2 grams. If you're using H2, it's 2 grams. Now follow me. So 1 mole of hydrogen is 2 grams, 1 mole of nitrogen is 28 grams. Now, step 1 says to find what? The number of moles of each reactant. Number of moles is mass over molar mass. We have done that yesterday. Let's find number of moles for nitrogen and number of moles for hydrogen. That will be mass of nitrogen all over molar mass of nitrogen. And number of moles for hydrogen will be mass of hydrogen all over molar mass of hydrogen. So number of moles for nitrogen, class, will be mass of nitrogen. They gave us 3.2 grams of nitrogen. So 3.2. What's molar mass of nitrogen? 28 grams. So we're going to say 3.2 divided by 28. Where's my calculator? 3.2 divided by 28. Okay, see my calculator here. 3.2 divided by 28. That will give you 0.114. 0.11428 moles. Coming to this side, number of moles of hydrogen. Mass of hydrogen they gave us is 2.5. Molar mass of hydrogen is 2 grams. For 1 mole of hydrogen is 2 grams. We're going to say 2.5 divided by 2. This gives us 1.25 moles. After getting number of moles of each reactant, class, notice that we're not doing for ammonia. Why? Because your limiting reagent is always on the left-hand side of the reaction. Your limiting reagent is always on the left-hand side of the reaction. It's not time to divide by the stoichiometric coefficient. Divide by the stoichiometric. Class, the stoichiometric coefficient of nitrogen here is 1. And stoichiometric coefficient of hydrogen here is 3. So this guy divided by 1, this guy divided by 3. This divided by 1 is still 0.11. So nitrogen is still 0.11428. But 1.25 divided by 3. Hydrogen is 0.4166 moles. Class, who is the smallest? This guy is smaller, right? 0.11428 is smaller than 0.4116. The person with the least value becomes the limiting reagent. So class, it is clear that nitrogen is the limiting reagent. It's the person that will finish first. Nitrogen is the person that will finish first. That's our limiting reagent, nitrogen. Just to be sure, just to come again, class. How do you determine limiting reagent? I give you 3 steps. First, find number of moles of each of the reactant. Only the reactant. Don't do product. Products cannot be your limiting reagent. Find number of moles of each reactant. You have 0.11428 and 1.25 moles. Because what's number of moles? Mass over molar mass. Mass over molar. What's mass of nitrogen? It gave us 3.2. What's molar mass of nitrogen? 28. What's mass of hydrogen? 2.5 grams of hydrogen. What's molar mass of hydrogen? 2 grams. So 3.2 divided by 28, you have this. 2.5 divided by 2, you have this. Now divide by the stoichiometric coefficient. What is stoichiometric coefficient? The number behind the element. This is 1 nitrogen, 3 hydrogen. Divide this by 1, divide this by 3. The person that produces the least value becomes limiting reagent. Please, let's not stretch this too much. It is very, very straightforward. Class, that's limiting reagent for you. Now, they also ask us to find the mass of ammonia produced. Class, what is very important is that the person that is limiting reagent is the person that will determine the mass of ammonia that will be formed. The person that is the limiting reagent is the person that will determine the mass of ammonia that will be formed. And the person is nitrogen. So nitrogen is the one that will determine the mass of ammonia that will be formed. Why? I told you. The limiting reagent is the one that determines the maximum mass of product, the maximum amount of product that is produced. Remember, limiting reagent is the one that determines the maximum amount of product that is produced. So let's go about getting our limit, our mass of ammonia formed. Class, as usual, from the balanced chemical equation, just like we used to do. What mass of nitrogen gives what mass of ammonia from the balanced chemical equation? From the balanced chemical equation, class, nitrogen is 28. 28 gram gave ammonia is N is 14, H is 1 times 3 is 3, 14 plus 3 times 2, everything will give you 34 gram if you do your math well. From the balanced chemical equation, 28 gram of nitrogen gave 34 gram of ammonia. Now, 3.2 gram of nitrogen is available. 3.2 gram of nitrogen is available. What mass of ammonia will be formed? We don't know. Call it X. It's now time to cross multiply. So say 28 times X is 28X equals 3.2 times 34. 3.2 times 34. Divide both sides by 28. So 3.2 times 34 divided by 28. 3.2 now divided by 28 will give you 3.8857 gram. Class, this is the mass of ammonia that is formed. That is the mass of ammonia that is produced. Let us now go to other stoichiometric calculations. While you are writing this, let me quickly touch on mole ratio. It's very simple. Class, if they ask to find the mole ratio of any compound, the mole ratio, the symbol for mole ratio is X. Mole ratio is simply number of moles of a substance all over total number of moles. So mole ratio of a substance A is number of moles of that substance divided by total number of moles. I will explain, don't worry. Class, if a mixture contains components A, B, and C. Component A has number of moles Na. Component B has number of moles Nb. Component C has number of moles Nc. So we have Na, Nb, Nc. Na means number of moles of A, Nb means number of moles of B, and Nc means number of moles of C. So a mixture contains three components, A, B, and C. Class, what will be the total number of moles of that mixture? Total number of moles of that mixture will be Na plus Nb plus Nc. But class, a mixture contains three components, A, B, and C. Total number of moles is Na plus Nb plus Nc, meaning number of moles of A plus number of moles of B plus number of moles of C. Now they can ask to find the mole ratio of A in the mixture. The mole ratio of a particular component in a mixture containing other components. The symbol for mole ratio is X. Sa means mole ratio of A. The mole ratio of A is number of moles of A divided by total number of moles of the mixture. The mole ratio of B is number of moles of B divided by total number of moles of the mixture. The mole ratio of C is number of moles of C divided by total number of moles of the mixture. Please take note. That's just what you should know about mole ratio. I believe you are not writing this, so I can go to all stoichiometric calculation. Class, what we have been doing so far is mass to mass stoichiometry. Class, sometimes I can give you mass to volume. I want to give you different types of stoichiometric questions. Given that the mass of this is this, find the volume of this formed. Molar volume, it's time to reach to molar volume 22.4 dmp or 22.4 liters. It is time, it is time, it is time. Other stoichiometric problems. Our next topic is all stoichiometric calculations. See, we are covering. All stoichiometric calculation, other stoichiometric calculations. We are going to other stoichiometric calculations. Other stoichiometric calculations. Should I be done writing this now? This is mole ratio for you. Let's take some set of questions down to buttress the point we are trying to raise. Calculate the volume of oxygen measured at STP. Calculate the volume of oxygen measured at STP. STP means standard temperature and pressure. On eating 18.5 gram of nickel 3 oxide, on eating 18.5 gram of nickel 3 oxide, calculate the volume of oxygen measured at STP on eating 18.5 gram of nickel 3 oxide. Look at nickel 3 oxide. If you are following this class, you will know that this reaction is an heterogeneous reaction. Heterogeneous reaction because all the components of the reaction are not all in the same physical state. This is solid to give solid and gas. So everything here is not just in one physical state. So this is an heterogeneous reaction. Class, we have to calculate the volume of oxygen at STP on eating 18.5 gram of nickel 3 oxide. There's one more thing I need to give you. Nickel, take nickel as 58.7 and take oxygen as 16. Take nickel as 58.7, take oxygen as 16. Class, it's now time to use what we call the molar volume. Are you aware, class, that 1 mole of any substance is equivalent to 22.4 dm cube or 22.4 liters? It's time to also tell you and note that dm cube and liters have the same value in chemistry. Dm cube means decimeter cube, or liters, they have the same value in chemistry. Just like cm cube, centimeter cube, and milliliter and ml, they have the same value in chemistry, class. So if someone tells you 5 cm cube, they are indirectly telling you 5 milliliter. Centimeter cube and milliliter have the same value in chemistry. They mean this, they have the same value. dm cube, decimeter cube, and liter have the same value. Please take note. So class, I also want to inform you that sometimes I can give you a volume in cm cube and ask to convert to dm cube. Please note that 1000 centimeter cube is equivalent to 1 decimeter cube, and 1000 milliliter ml is equivalent to 1 liter. Please take note. 1000 centimeter cube is equivalent to 1 decimeter cube, and 1000 mil equivalent to 1 liter. Please take note. So if someone gives you 300 cm cube and you have to convert it to dm cube, it's just to divide this guy by 1000 and you convert it to dm cube. That will be 0.3 dm. Or someone gives you 250 mil and say go to liter, mil to liter, divide by 1000, I am going to have 0.25 liters. This is how you go from mil to liter. This is how you go from cm cube to dm cube. 1000 centimeter cube equals to 1 dm cube. 1000 mil equals to 1 liter. Please take note. Please take notes. Please take notes. Class, what am I telling you? Because we're entering the side of volume now where you will need this knowledge. 1 mole of any substance contains 22.4 dm cube at STP, or 22.4 liters. Class, follow me carefully. They ask us to calculate the volume of oxygen measured at STP on eating 18.5 gram of nickel 3 oxide. Don't also forget that 1 mole of any substance is also equivalent to the relative molecular mass or the relative atomic mass I told you yesterday of that substance. I told you in day 1 that relative molecular mass is used for molecules and relative atomic mass is used for atoms. I told you yesterday. We use relative molecular mass for molecules, we use relative atomic mass for atoms of elements. But 1 mole of any substance is equivalent to relative molecular mass or relative atomic mass of that substance. So it means that 1 mole of carbon, for example, is equivalent to 12 grams of carbon. But 1 mole of CO2 What is CO2? C is 12, O is 16 times 2, 32, 12 plus 3 is 40. So 1 mole of CO2 is equivalent to 44 grams of CO2. But this 12 grams is relative atomic mass, this 44 grams is relative molecular mass, but this is a molecule, this is an atom. So this 12 grams is relative atomic mass, this 44 grams is relative molecular mass. So 1 mole of any substance contains 22.4 dm³ or 22.4 liters at STP. And 1 mole of any substance is still equal to relative molecular mass or relative atomic mass. Meaning that 1 mole of carbon is 12 grams, 1 mole of CO2 is 44 grams. But 1 mole of carbon is also still equal to 22.4 dm³ at STP. It means that 12 grams can be equivalent. This does have nothing to do with the question, I'm just teaching you something. 12 grams of carbon can equivalent to 22.4 dm³ of carbon. And 44 grams of CO2 is still equal to 22.4 dm³ of CO. Please take note. 12 grams of what? Carbon is equal to 22.4 dm³ of carbon. 12 grams of carbon is equal to 22.4 dm³ of carbon. 44 grams of CO2 is equal to 22.4 dm³ of CO2. Please take notes. This can also be true for any other atom or element as the case may be. What can we deduce from all this, class? Let's go back to our main question. Calculate the volume of oxygen measured at STP on eating 18.5 grams of nickel 3 oxide. Class, let us leave 18.5 grams of nickel 3 oxide first. From the balanced chemical equation, we have 2 moles of nickel 3 oxide. 2 moles of nickel 3 oxide means that 2 moles of nickel 3 oxide will give what volume of oxygen? Let us ask ourselves, if we have 2 moles of nickel 3 oxide, what volume of oxygen will be obtained from 2 moles of nickel 3 oxide? Plus, on the balanced chemical equation, 2 moles of nickel 3 oxide gave 3 molar volume of oxygen. But 1 mole of any substance is 22.4 dm³. If we have 3 moles of oxygen, that will be 3 moles will give us what? X, cross multiply. 3 times 22.4. X times 1 is X. So X equals 3 times 22.4 dm³. Because this is relating mass, mole to volume. This is mole to volume stoichiometry. I'll come again in case you are lost. Class, on the balanced chemical equation, we have 2 moles of nickel 3 oxide. Gave 3 moles of oxygen. But class, oxygen is a gas. The gaseous part of the reaction will be converted to molar volume, 22.4. So for every mole of oxygen is 22.4 dm³. So if we have 3 moles of oxygen, that will be 3 times 22.4, giving us 67.2 dm³. So class, we can say that 2 moles of nickel 3 oxide gave 67.2 dm³ from the balanced chemical equation. Now if you have 18.5 grams of nickel 3 oxide, what volume of oxygen will be formed? Calculate the volume of oxygen measured. Class, we must convert this 18.5 grams of nickel 3 oxide to moles. We must convert 18.5 grams of nickel 3 oxide to moles. Class, mass of nickel 3 oxide is 18.5. We must find the molar mass of nickel 3 oxide. Ni2, Ni is 58.7 times 2 plus O3. O is 16 times 3. Now everything multiplied by 2 because it's 2 outside. Then we have calculated 58.7 multiplied by 2 equals to 117.4 plus 16 times 3 is 48. Everything multiplied by 2. 117.4 plus 48 is 165.4. Multiplied by 2, 330.8. Class, the molar mass of nickel 3 oxide is 330.8. But the mass given is 18.5. How do we get number of moles? Mass all over molar mass. What's the mass given? 18.5. What's the molar mass? 330.8. So number of moles will be 18.5 divided by 330.8, giving you 0.0559 moles. So class, 0.0559 moles of nickel will give what volume of oxygen? We don't know, we'll call it S. From the balance equation, we have 2 moles of nickel 3 oxide we all know how we got 7.2 dmq because we have 3 moles of oxygen, and for every mole of any gas at STP contains 22.4 dmq. So 3 moles of oxygen will be 3 times 22.4, so 7.2 dmq. So 2 moles of nickel 3 oxide gave 3 times 22.4, so 7.2 dmq. Class, you don't have to go and be doing this in the exam. Just understand chemistry that you have 3 years, multiply 3 times 22.4. If you have 4 here, 4 times 22.4. If you have only 1 here, 1 times 22.4. So 2 moles of nickel 3 oxide gives 7.2 dmq of oxygen. Class, we only use this particular 22.4 when they say it at STP. Find the volume at STP. And we only use it for the gaseous part of the reaction. You can see. This guy will not change into 2 times 22.4. We'll still say 2 moles. 2 moles of nickel 3 oxide gave, because this is a solid. This one is only for gas. Oxygen is a gas. So we still use 2 moles here. 2 moles of nickel 3 oxide gave 3 moles of oxygen. But 3 moles of oxygen is what? How many in volume? 3 times 22.4 is 7.2. Now, we need to go and find the number of moles of nickel 3 oxide from 18.5 grams of nickel 3 oxide. That's what we did here. Number of moles is mass over molar mass. 18.5 divided by molar mass, 330.8. We got the 0.0559 moles. So 0.0559 moles will give X. We don't know. Cross, multiply. 2 times X is 2X. Equals to 0.0559 multiplied by 67.2. Divide both sides by 2 to make X unit of the formula. So you have 0.0559 multiplied by 67.2 equals to 3.75648. Now divided by 2. Will give us 1.87824 dmq. Class, this is the volume of oxygen that will be formed. This is the volume of oxygen that will be formed. I hope we are still there. 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 If you are with me, say, sir, we are with you. If you are with me, say, sir, we are with you. Now let us proceed. Let us now go to let's take 1 or 2 more questions. Let's take more questions. Let us take more questions. Given the reaction, 2NaCl plus H2SO4 to give Na2SO4 plus 2HCl. Calculate the volume of HCl that will be obtained at STP. Calculate the volume of HCl that will be obtained at STP. From 5.85 grams of sodium chloride. Take sodium as 23.0. Take chlorine as 35.5. And take molar volume of gas at STP. Molar volume of gas at STP is 22.4 dm cubed. Molar volume of gas at STP 22.4 dm³. Class, we are given an equation 2NaCl plus 8,2SO4 to give Na2SO4 plus 2HCl. Calculate the volume of HCl that will be obtained at STP from 5.85 grams of sodium chloride. Take Na as 23.0, Cl as 35.5, and molar volume of gas at STP as 22.4 dm³. Class, HCl is the gas here. Calculate the volume of HCl that will be obtained at STP from 5.85 grams of sodium chloride. So sodium chloride is the focus and HCl. So it's between sodium chloride and HCl. Class, this is a mass volume stoichiometry. The other one they gave us is what? Mole volume stoichiometry. That one was mole to volume, where we said 2 moles of nickel 3 oxide gives a 7.2. So this mole on this side and this volume on this side. But this one now is mass volume stoichiometry. Mass volume stoichiometry. Mass to volume stoichiometry. What volume of HCl will be obtained from 5.85 grams of sodium chloride? Before we get the volume that will be obtained from 5.85 grams of sodium chloride, let us ask ourselves one question. What volume is currently obtained from what mass of NaCl? Class, Na is 23, Cl is 35.5. If you do the math very well, 23 plus 35.5 will give 58.5. 23 plus 35.5, 58.5 multiplied by 2 will give you 117. Class, from the balanced chemical equation, 117 grams of NaCl, 117 grams of NaCl gave what volume of HCl? Remember that this is 2 moles of HCl. But the molar volume says that 1 mole is 22.4. So 2 means 2 times 22.4. That will give you what? 4.8 dm³. So 117 grams of NaCl gave 44.8 dm³ of what? HCl. Now they're asking us from 5.85 grams of NaCl, what volume will be obtained? Call it what? X. You don't know. Call it X. We don't know. You're now going to cross multiply. You're going to say 117x equals to 5.85 multiplied by 44.8. Divide both sides by 117. 117 cancels 117. So you have 5.85 times 44.8 equals to 262.08. Now divided by 117. Now give it 2.24 dm³. This is the volume. This is the volume of HCl that will be formed. That is the volume of HCl that will be formed. That is the volume of HCl. How many people are with us now? How many people are with us now? Yes, yes, yes. Yes, yes, yes. If you're just coming in, start watching it from the beginning. No, don't just fast forward it. This is not a Nollywood movie. Don't just fast forward it. Start watching from the beginning. Start watching from the beginning. We have just 2 more topics to go and we are done. 2 more topics to go and we are done for today's target. 2 more topics to go and we are done for today's target. Concentration of solution, class. Concentration of solution. Class, we have many types of concentration, but for your Jamb, there are only 2 major concentrations you need to know. Molar concentration, called molarity. Molar concentration, also known as molarity. And the second one is mass concentration. The second one is mass concentration. Class, the molar concentration formula is the number of moles divided by the volume. While the mass concentration formula is mass divided by volume. Now, because of this number of moles per volume, the unit will be mole per dm cube. Because this is mass all over volume, this will be grams per dm cube. Please note that if you are giving your volume in cm cube, never solve until you convert to dm cube. If you are giving your volume in cm cube, change it to dm cube. I taught you how to change it in this video. Divide by 1000. From cm cube to dm cube, divide by 1000. Now, dilution formula. So that we'll just take questions and we are done. Dilution formula and we are done with today's target. Class, dilution formula tells us the formula says C1V1 equals to C2V2, where C1 represents initial concentration, V1 represents initial volume, C2 represents final concentration, and V2 represents final volume. Class, what is dilution? Dilution is when you add water to already concentrated solution. When you add water to already concentrated solution, you are going to increase the volume of the solution, but you reduce the concentration. Addition of water to a solution that is concentrated will increase the volume. It will look more, right? But the concentration will drop. If you are taking a gari and milk and sugar, and you're enjoying the sugar, you're enjoying the milk, everything is going well. Your sister now added water so she can join you. Yes, you're going to have more things to drink, but you will not enjoy it as you enjoyed before. The concentration will drop, right? Exactly. So class, initial concentration is the concentration of the solution before you added water. Initial volume is the volume of the solution before you added water. Final concentration is the new concentration after water was added. Final volume is the new volume after water was added. This is what we call the diluting volume. The diluting volume is the difference between the final volume and the initial volume, V2 minus V1. We call it VD. Diluting volume is VD. It's final volume minus initial volume. Diluting volume is the volume of water that was added to the solution. The volume of water that was added to the solution is called the diluting volume. The volume of water that was added to the solution is called the diluting volume. Yes. The volume of water that was added to the solution is called what? The diluting volume. The volume of water that was added to the solution is called the diluting volume. And it is final volume minus initial volume to help you to know what was added. Let us take question and we are done for today. Let us take question on these things I taught you and we are done for today. Congratulations, we finished our target for day 2. Where are those people that said, sir, can we cover? Are you still there? When we wanted to start, I was posting the topics to cover this. I think some students said, sir, are you sure we can cover? Are you seeing it already? This is day 2. Seeing is believing. Seeing is believing. Let us take questions on this aspect. Let us take questions on this aspect. Let's look for good questions on this aspect and take it. While I'm looking for questions, you still have time to be writing. While I'm looking for questions, you still have time to be writing. First question, find the molarity. Find the molarity of 0.5 mole NaOH in 250 cm cube solution. Find the molarity of 0.5 moles NaOH in 250 cm cube solution. Find the molarity of 0.5 mole NaOH in 250 cm cube solution. Class, remember I predicted this, that they will not give you in dm cube, they will give you in cm cube. Convert this to dm cube, divide by 1000. You're going to have your volume will be 0.25 dm cube. Your number of moles already is 0.5 moles. What's your formula for molarity? Number of moles divided by volume. Your molarity is number of moles divided by volume. So your molarity will be number of moles divided by volume. What's number of moles? 0.5. What's your volume? So 0.5 mole divided by 0.25 dm cube. 0.5 mole divided by 0.25 dm cube. So you're going to say 0.5 divided by 0.25. And the molarity is 2 m. The symbol for molarity is capital letter M, or you say 2 mole per dm cube. That's the two symbols for molarity. Those are the two symbols for molarity. Those are the two symbols for molarity. Another question. This one is straightforward. Another question. Find the molarity of 9.8 gram H2SO4 in 500 cm cube solution. Find the molarity of 9.8 gram H2SO4 in 500 cm cube solution. Find the molarity of 9.8 gram H2SO4 in 500 cm cube solution. Class, molarity, as you know, is number of moles all over volume. But we don't have number of moles, we have volume, and we don't even have volume in dm cube. Never use your volume in cm cube, convert to dm cube. Always convert to dm cube, divide by 1000.